So good afternoon all. So we have learned about Hamiltonian, right? So my topic is basically there are two topics. First one is the application of Hamiltonian, and that is motion of a particle in central force field. So except this, all other 4 to 5 applications have already been taken by Sneha. So today we will be discussing about what is the motion of a particle in a central force field. So let's just consider a particle which has mass m and it is attracted to a force which is attracted to a fixed point. Let's say it is O. We can consider that point as O, and the force which is acting on that point is an inverse square force. So do anyone know what is inverse square force? So inverse square force means which has a force which is inversely related by the square of the distance. So the simple example is
gravitational force.
So we can just consider the force which is acting on that point on the mass m is an inverse square force, which is F is equal to minus G m by r square, right? So this is an inverse square force, and as we all know, this is a constant. Okay, we already know the mass is m, so we can consider all this point as a constant. So we can write it as minus k by r square, right? And where k is g mm. So what is the peculiarity of a central force field? What is the main peculiarity of a central force field? So the main peculiarity is like in central force field, all the forces, the central force will be conservative. Okay, the central force will be conservative force. So we have already learned about the condition for conservative force. Does anyone know that what is the condition for conservative force? F is equal to minus dou v by dou r. We have learned this, right? And so here we can write it as the force is minus k by r, right? From this we can say that v is equal to minus k by r. We can say that here v is equal to minus k by r, or we can simply say dr is equal to minus k by r, because we are taking it with respect to r. So, and now we consider that if a particle, we consider the particle is of mass m, so that particle is moving in a central force field. We already know that a central force will be conservative force, and then the Lagrangian, we are going to find the Lagrangian of that particular particle which is moving in a central force field. So it will be moving in a plane polar coordinate. So what is the plane polar coordinate? What are the components?
R theta.
R and theta. So the components will be r comma theta. So these are the components of that plane polar coordinates, and we already know what is the Lagrangian, how to find Lagrangian, right? What is Lagrangian? L is equal to
T minus B.
T minus V. We already know that what is V, right? We have already found from the conservative law what V is. So V we can write as V of r is equal to minus k by r, and T we already know what is T, half mv square. Here instead of V we have two components, which is r and r theta. There will be two components, r and r theta. So we can write T as half into m into, as we are taking V means the derivative of what position, right? So we have to write it as r dot. So r dot square plus
Theta.
r
R theta.
square theta
Theta.
dot square, because r theta is the angular velocity, and we can simply put the values of t and v here. So we can write it as L is equal to
Half M.
t minus v of r, which is equal to
Half M.
half into
M.
m into
R dot theta.
r dot square plus
R
square
theta dot square
theta dot square plus k by r. Why plus k by r? Because minus and minus will be plus. So it will become plus k by r. So this is the Lagrangian of a particle which is moving in a central force field. Now what we have to find is the Hamiltonian, right? So in order to write the Hamiltonian, we have to find r dot and theta dot, and it must be replaced by the generalized momentum. Like if we have to convert it into Hamiltonian function, Hamiltonian equation, we have to find the generalized momentum p r and p theta. Here the components are r and theta, so we have to find p r and p theta. So the equation to find p r is equal to dou L by dou r theta, and p theta. How can we find p theta? P theta will be dou L by dou
theta.
theta. So what will be the answer? From here what will be the answer? Dou L by dou
Dou R dot.
r dot dou L by dou r dot. Here what will be the answer? It will be, here 2 and 2 will be cancelled out, right? So it will become m r dot. It will become m r dot. And in the case of p theta, it will become r square will be here, and here it will be
M
2 theta. So 2 and 2 will be cancelled out.
M
So it will become
R square
m r square
theta dot.
r square theta dot. From here we can find the values of r dot and theta dot, right? How can we write the values of r dot and theta dot?
R dot is equal
R
to
is equal to,
P R by M.
yes, p r by m, and theta dot is equal to
P theta by M R square.
theta dot is equal to p theta by m r square. So these are the two values, r dot and theta dot. And now we already know how to find the Hamiltonian, right? Hamiltonian h is given as, we know Lagrangian is L is equal to t minus v. So h is equal to t plus v. H is equal to t plus v. So this is the equation for Hamiltonian, and we already know what is t, what is v. But what we have to do is we have to substitute the value of r theta, r dot and theta dot, which we have already found here. So we have to substitute the value of r dot and theta dot in this equation. So it will become half into m t, we already know it will be r dot square, right? R is pr by m, so it will become pr by m square plus r square
And
P theta.
P theta by M R square all square.
P theta by m
R square
r square
whole square.
whole square. And
Plus
what we have? Plus v by r.
K by R.
V by v of r. So we already know the value of v of r, right? What is it?
K by
Minus k by r. So we can simply substitute the values
minus K by R.
k by r. Clear? So this is the Hamiltonian equation for this particle motion of the particle in the center force field. Now what we have to find is the Hamilton's equations of motion. Okay? So for that we have to find, you already know, q dot k and p dot k. So how to find q dot k? Q dot k is equal to dou h by dou pk and P of P dot K is equal to dou H by minus dou H by dou Qk. So these are the equations for Hamilton's motion
Equation of motion.
And in the case of motion of a particle in a separate force field, the value of k here, k will be r and theta. So there are two variables with the r and theta. So we have to find r dot, pr dot, and theta dot and p theta dot. Okay. So first we are going to find r dot. R dot is equal to dou H by dou PR. So from here, what will be the value of R dot? Dou H by dou PR. Here the PR term is coming only in this one. So what will be the answer? Square will be QPR by M, Q and 2 will be cancelled out. We can write it as PR by M. Okay, so let's consider this as equation A or equation 1. And the another one is we have find R dot. Now we have to find PR dot. So PR dot is equal to minus dou H by dou R. Minus dou H by dou R. So what will be the value of minus dou H by dou R? We can write it as dou by dou r of the whole Hamiltonian, which is here. We can write as PR by M square plus P square theta by 2mr square minus k by r. Okay. And we will get it as minus here this term doesn't contain any of the r value, so we don't have to consider that. So we will get minus of t square theta by m r cube and plus k by r square. Okay. Here, if we take the minus 2 inside, it will become p square theta m r cube minus k by r. So this is the value of PR dot. Let's consider this as equation B. So we have got the value of R dot and PR dot. Now what we have to find is theta dot and P theta dot. Let's write this. Theta dot is equal to dou H by dou P theta, and here from here can we find what is the value of dou H by dou P theta?
R square and
If we take what it will be, 2 and 2 will be cancelled out and it will become simply P theta by M R square. So it will be P theta by M R square. That is the value of theta, and the another one is P theta. To find the value of P theta, we have to find minus dou H by dou theta. So what is the value of minus dou H by dou theta? Here, is there any term which contains theta? No, right? There is only P theta. That's an individual variable. There is no variable with theta term in that. So we can say this as 0. This is our equation C and this is our equation D. From both of these equations C and D, we can find that P theta is a constant, because from here if we take these two and equate these two, we can find this as P theta is equal to 0, and that means 0 means P we can say it as a constant, right? So what does that mean? It means that here p theta is the angular momentum. Okay, in this equation p theta is the angular momentum and that is equal to 0. Which means that angular momentum is conserved throughout the central force field. Okay, in the central force, the angular momentum is totally conserved. Now, from the equation A and B, which are equation A is equal to R dot is equal to PR by M and PR dot is equal to P square theta by M R cube minus K by R. From both of these equations, we can find that we can take this PR to this side, right? So we can write it as PR is equal to R dot M, right? PR is equal to R dot M. So here it is PR and it is PR dot. So what we are going to do is to make both of these left hand side equal. For that we are taking derivative of this one. So we can write this as
the PR dot is
PR
equal
dot is equal to R double dot. It will become R double dot M. Okay. Now we have equals. Both these equations have become equal on which side? Left
Yes.
side. So we are going to
equate.
equate between the left and right side also. So we can write it as R double dot M is equal to this equation. This will be P square P theta square by M R cube minus K by R. Or we can simply write it as, if we take this equal term to other side, we can write it as R double dot M R double dot minus P square P theta square by M R cube plus K by R square is equal to 0. Okay. So this is the Hamilton's equation of motion.